Okay, we'll wait for another 2 minutes. So only 10 people have joined. I want others to join because attendance is compulsory. Please use your NI ID to join the meeting always. Okay. Okay. So in this, we are in the last part of the second module. So what we have learned in this module is like, what is the intuition behind convolution? So what is this term called convolution? Where this convolution is applied? What are the application of this convolution? Then after that, what did we see? So we saw how to do convolution in discrete time and convolution in continuous time. Then we saw linear differential equation. Then that was yesterday's class. So before that, we saw the properties of LTI system like causal, memory. So these are the things which we have learned. So coming to the last part, so I had left this one, and there is after this one there is SLE. So that self-learning, what I will do is like I will post that one for that self-learning what you have to do. So today we will see system viewed as interconnection. Then what is the step response for the system? Okay. So these two things we will see in today's class. First one, system viewed as interconnection. Okay. So from derived distributive property, so a system can be represented in block diagram. So if the input is x of n and your output is y of n, and your impulse response is h1 of n and h2 of n, from the distributive property, if the block is like this, you can add those things. So when they are in parallel, h1 of n and h2 of n, you can add it, provided they give you plus sign. If it is minus sign, you can subtract it, like h1 of n minus h2 of n. So when they are in parallel, add or subtract. So this is from the distributive property. So that derivation you don't have. Then from the associative property, if the two impulses like h1 of n and h2 of n are in series, so what can you do? You can convolve. So this equivalent diagram will be x of n, output y of n, and your h of n will be convolved with h2 of n. So these two you have to remember to solve the problems. Okay. So if they give you this kind of problems, it's like bumper to you, like it's easy to solve. Okay. So remember, when these two are in parallel, to add or subtract, and when these two are in series, you have to convolve them. Okay. This is convolution operation. Here it is addition or subtraction. So using this property, we will solve problems today. Okay. So in the exam, they will ask you find the overall impulse response of the following. So what is the impulse response? h of t or h of n. Okay, so what they have given here in the question: input x of t, output y of t, h1, h2 and h3. So I have already drawn this because it takes time for drawing, so I have already drawn that one. So we will go step by step. Okay, so first thing what we have to do, this h1 and h2, since they are in series, we are going to convolve this one. So write the block diagram. So input x of t, output y of t, so this plus everything will be stay as it is. Convolve this one, h1 convolution h2. So this is h1 convolution h2. Okay, so this is your step 1. Then what is your step 2? So these two, h1 convolved with h2 is parallel with h3. So what sign you have got? Plus. So h1 convolved with h2 plus this h3. Okay, so this is your step 2. So your final impulse response is h of t is equal to this one, h1 convolution h2 plus h3. Okay, so we will see this sum once again. So there is input x of t, there is output y of t, you have h1, you have h2 and h3. So if h1 and h2 are in series, you convolve them, and then you have to write step by step. We'll go. Then h3 is in parallel. So if it is in parallel, you have to add that. So easy, right? So if this comes, it's like a bumper to you. Okay, we'll go to the second question. Okay, so now the complexity goes on. Okay, second sum, third sum, you see. Okay, so now you see this h1 is there as it is, h2 h3 they have given in parallel, h4 and h5 in series, and this is connected in parallel. So we will solve this step by step. So let us go to step 1, and we will take this h2 and h3 in parallel and h4 and h5 in series and solve that. So h1 you write as it is, this block. So h2 parallel h3 is h2 minus h3. Why it is minus h3? Here the symbol is minus. So please observe, okay, this symbol, what they have given, plus or minus. So it is h2 minus h3. Okay, then what is this h4 and h5? You have to convolve them because they are in series. So h4 and h5, it's convolution. Okay, so once again, see this one, h1 I have written as it is, h2 minus h3 I have written here, then h4 convolve with h5. So this is our step 1. So let's go to step 2. So in step 2, what we will do is, these two are in series. Okay, so h1 convolve with h2 minus h3. So h1 convolved with h2 minus h3, then h4 and convert h5, it will remain as it is. Okay, so just go and do step by step. And finally, what these two are in? These two are in parallel. So h1 convolved with h2 minus h3 plus h4 convolved with h5. So step by step you go on doing that, so that it will be easy to get the answer. Okay, so what we have done here, h2 is parallel with h3, so h2 minus h3 here, and h4 is in series with h5, so I have convolved here. I have written step 1. So steps 2, h1 and h2 minus h3, they are in series, so I have convolved that one and I have written. Then finally these two are in parallel, so I have added these two. Okay, that's it. So this type of sums is easy. Okay, so let me increase the complexity of the sum now. Okay, so in the exam there might be a problem, okay, where this single term comes, like there is nothing. Okay, so this represents del of t. This is for your information. So this is del of t or del of n. So if they given x of t, write it as del of t. If they have given as x of n, write it as del of n. So we will solve this step by step. So step 1. In step 1, what we will do? See this h1 and h2. So they are in series. So h1 convolved with H2. So del of T, let it be as it is. Okay. Then we'll go to this H4 and parallel with H5. So it is H4 plus H5. So H4 plus H5. So H3 I'll keep as it is because I'm going to solve in next step. Okay. Step 2. Now this parallel line, let it be as it is. So second line also let it be as it is. For the third line, H3 is in series with H4 plus H5. So what it means? H3 convolved with H4 plus H5. So H3 convolved with H4 plus H5. So these three we have done. So all these three are in parallel. So see the sign properly. You have plus here and minus for the last term. So it is del of T. So for the first line plus H1 convolved with H2 minus H3 convolved with H4 plus H5. So do this step by step so that you will not miss and you will get complete marks. Okay. Next, let us go to next problem. So this problem, in exam, they will not ask simple problem. So always there will be some twist. Okay. In signals, you can't expect direct problems at all. Okay. So this block diagram they'll give, and also they'll give them values of H1, H2, H3 and H4, and they'll say find the impulse response. Okay. So what is your main motive behind solving this problem? First, solve this block diagram and you'll get the impulse response like this, and then substitute what is H1, H2, H3, H4, then solve it. Okay. Now let us solve this problem step by step. Okay. Okay. Now we will take this one, this block diagram here. This H3 and H4, they are parallel. So it is H3 plus H4. So write the block diagram as it is. H1, H2, then H3 and H4, they are in parallel. So it is H3 plus H4. Okay. So here they have given plus sign. Okay. Then this is our step 1. So step 2, H1 let it be as it is. Here H2 is in series with H3 plus H4. So H2 convolution H3 plus H4. So H1 is as it is. So your second one, H2 is convolved with H3 plus H4. Finally, these two are in parallel. So we'll add these two up. So H1 plus H2 convolved with H3 plus H4. Okay. So this is your final expression. But what they have given? They have given the values of H1. They have given the values of H2. They have given the values of H3 and they have given the value of H4. So we have to substitute this thing in this expression and we have to solve it. So let us substitute that one. Okay. So first let us write the expression. Okay. So what we have got? H1 plus H2 convolve with H3 plus H4. So sometimes you may be confused. Why can't you add this H1 plus H2 and then you can convolve? Always, keep this BODMAS rule in your mind. So first you have to do bracket, then off is not there here, then division, multiplication. So instead of multiplication, here you take as convolution so that you will not get confused. Then you do addition, then go for subtraction. So first what you have to do? Bracket. So bracket is H3 plus H4. So H3 plus H4. Okay. So observe here. H3 is 2 into del of n, which they have given in the question. And your H4 is this one, minus 2 into 1 power half power of n, u of n minus 1. So I have added it up, H3 plus H4. Then what we have to do? Bracket of division. Division is not there. Multiplication. Instead of multiplication, we will take this convolution. Okay. So H2 convolve with H3 plus H4. So h2 they have given as half into del of n minus 1 by 4 into del of n minus 1. So this is your h2 convolve. So convolved with the previous term h3 plus h4. So you convolve with the previous term 2 into del of n plus minus 2 into half power n into u of n minus 1. Okay. Now we will first thing you have to simplify, okay, in step by step itself, so that finally it will be easy to solve. So you convolve half into del of n into 2 to 2 del of n is, so convolve with 2 del of n is 2 to get cancelled, it is del of n. Half del of n convolve with minus 2 into half power of n into u of n minus 1 is half of get cancelled minus 1 power of n u of n minus 1. Okay, then take this one minus 1 by 4 del of n minus 1, you convolve with 2 into del of n. So minus 1 by 4 into 2 is minus half, and del of n minus 1 convolve with del of n, you will get del of n minus 1. Then minus 1 by 4 del of n minus 1, you convolve with the last term. So minus 2 into minus 1 by 4, so which is plus 1 by 2. Then half power of n, del of n convolved with u of n minus 1, it is u of n minus 2. So you write this one. Then finally what we have to do, take this h1 plus add all the other terms. So your h1 which is given as del of n plus half into del of n minus 1 plus your previous term del of n minus half power of n into u of n minus 1 minus half into del of n minus 1 plus half into half power of n into u of n minus 2. So add those two terms. So you add those two terms, you will get the final expression as 2 into del of n minus half into del of n minus 1. So this adding I have done here. So you can refer this PDF which I'll post this in your Moodle account. Please check that. So this things, it's simple. So I'll not do that. So you'll arrive with the answer. Okay. So what I'm suggesting you to is first see what is the problem. Then try to, simplify it by going in step by step manner. Okay. So based on those, whatever problems I have solved, I have given you some 2 homework problems. Okay. Please solve this. Okay. Same thing here, h1 and h2 are parallel. This is in series with h3. Then it is in parallel with h4. And I have given the value of h1, h2, h3 and h4. Substitute it and solve it. So yeah, if I have time at the end of this lecture, I'll solve this 5th question if you want. And 6th question at least you have to solve. Okay. So here it is your input here h of t. Here you have your output y of t. And same thing, block diagram is the same. Only your h1, h2, h3, h4, I have changed the values. So let us see this problem. If we have got time at last, I will solve this 5th question here. Okay. So this is easy. Okay. So, practice once. Okay. Now let me go to the second topic for today, which is the step response of a LTI system. So what is the step response? You have a LTI system here. What is your response to the step? So this is your step u of t. So or u of n. U of n will be like this. Okay. So what is the response for this signal? For this step, what is your output? So that is called the step response of a LTI system. So we will see. So please concentrate here so that it will be helpful in solving the problems. Okay. So now we have seen that y of n is equal to x of n convolution h of n. Now convolution is commutative. That means y of n is equal to h of n convolved with x of n. Ulta. X of n convolved with h of n. H of n convolved with x of n. This is commutative property. So what is our formula? Our convolution formula is y of n is equal to summation k varies from minus infinity to infinity x of k into h of n minus k. Okay. So now this is x of k convolved with h of k. Now what we have got? We have got h of k convolution with x of k. So what will be the difference here? Summation k varies from minus infinity to plus infinity h of k into x of n minus k. Okay. But we want the input to be the step because we are finding the response with respect to the step input. So x of k or x of n is equal to u of n because that is your input. Then x of n minus k will be equal to x of n minus k will be equal to u of n minus k. So that is the difference. So in this equation, I have to replace x by u. Okay. So if I replace this one, I'll get summation k varies from minus infinity to infinity h of k into u of n minus k. So I have written the same thing here. Y of n is equal to summation k varies from minus infinity to infinity h of k into u of n minus k. But what is this u of n minus k mathematically? If you write u of n minus k is equal to 1 for n minus k is greater than or equal to 0. Okay. So n minus k is greater than or equal to 0. Then n is greater than or equal to k. Then n is greater than or equal to k. So your term, this term can be simplified as your step response is equal to summation k varies from minus infinity up till n only. Okay, because your n is greater than or equal to k. So minus infinity to n h of k. So this formula you have to remember for solving the step response of the LTI system. So there will be a question. Find the step response of the LTI system described by some impulse response. So if you use this formula, s of n is equal to summation k varies from minus infinity to n h of k, you will directly end up with the step response. Okay. So this is for discrete time system. So this is the step response for discrete time system. What is the step response for continuous time? For continuous time, we have same thing. Derivation, everything is same here. If you see, y of t is equal to x of t convolution h of t. So we know that convolution is commutative. This means we can exchange h of t and x of t. So what is y of t is equal to integral minus infinity to infinity h of tau into x of t minus tau d tau. Okay, because we have interchanged it, otherwise it will be integral minus infinity to plus infinity x of tau into h of t minus tau. Here since it is commutative, we have to do ulta, integral minus infinity to infinity h of tau into x of t minus tau d tau. Now same thing, what is your x of, because we want to find the impulse response. Okay, your input will be the step. So your x of t is equal to u of t, and then x of t minus t tau will be equal to u of t minus tau. And since u of t minus, what does that mean? U of t minus tau is equal to 1 for t minus tau is greater than or equal to 0, or t is greater than or equal to tau, u of t minus tau is equal to 1. So your limits will be changed from minus infinity to t h of tau d tau. So this is your step response for continuous time system. So you have to remember this formula while solving the problems for step response for impulse. Step response for LTI system. Okay. So what is the meaning of this one? So if they give you them step response, it is nothing but the summation of your impulse response of the system, because h of k is nothing but your impulse response. Okay. So let us solve some 3 problems so you will get a better idea. Okay. So let me take this problem. Okay. So we will take this problem here. H of t is equal to e power minus 2t into u of t plus 1. So what is the first thing you have to do? First, you write the mathematical expression, then plot it. Here plotting is not necessary because we know the formula beforehand. So we will write the mathematical expression. So what is this? H of t is equal to e power minus 2t for t plus 1 greater than or equal to 0, because it is u of t plus 1. Okay, then t is greater than or equal to minus 1. So h of t is equal to e power minus 2t if t is greater than or equal to minus 1, otherwise it is equal to 0. So what is the question here? Always read the question. You have to find them step response. So whenever they give this question step response, you directly write the formula. So since they have given for continuous time system, so your step response will be equal to integral minus infinity to t h of tau d tau. So this expression I have derived before in the previous slide. You can refer it. Okay. So, but this t varies from minus 1, not from minus infinity, because t is greater than or equal to minus 1. So your integral changes from minus 1 to t. What is your h of tau here? E power minus 2 tau. So e power minus 2 tau d tau. So what is this integration? E power minus 2 tau divided by minus 2. So this limit changes from minus 1 to t. So if you solve this, so let me solve here. Minus of, I will take it outside. E power minus 2t minus e power minus 2 into minus 1. So this is equal to minus half e power minus 2t minus e power plus 2. Okay. So this is your answer. So whenever they give you such kind of problems, find the step response of a LTI system. The first thing, you write the formula directly, then you write the mathematical expression to get the limit, then substitute the limit here, and then you integrate, or you take the summation if it is for discrete time. Okay. So let me solve another two problems. Okay. So what have we got here? So they have given h of t is equal to t e power minus at u of t a greater than or equal to 0. So let me write the mathematical expression for this. Or h of t is equal to t e power minus at for t greater than or equal to 0, otherwise it is equal to 0. Okay. So this is not required actually. I have written. So now what is our expression for step response which we have derived? S of t is equal to integral minus infinity to t h of tau d tau. But your this thing, it ranges from 0 to t because t is greater than or equal to 0. So your overlapping will be from 0 to t. And what is your h of tau? T e power minus at. So since it is h of tau, it is tau e power minus a into tau d tau. Okay. So how can you solve this integration? So this is in the form of integral u into v. So how can you solve this one? U into integral of v dx minus integral of differentiation of u into integral of v dx. So using that formula, you have to solve this one. Okay. So let me solve this one for you. So first term u will be as it is, which is tau. Integral of v. So integral of e power minus a into tau, which is equal to e power minus a into tau divided by minus a. Then minus integral of u dash. So what is the differentiation of tau? It is 1, and integral of v dx. So e power minus a into tau divided by minus a. So this thing varies from 0 to t d tau. Okay. So if you simplify this one, you will get tau e power minus a into tau divided by minus same minus 1, you can take it outside. Again, integration of this one is e power minus a into tau divided by a square. Okay. Then from 0 to t. So if you solve this one, you should get e power minus at divided by a into minus t and minus 1 by a. So you solve this, you'll get this. Another one step is there. Okay. So what you have to do is you have to substitute the formula, take the limit and solve step by step. Okay. So let me go to another problem. So what is the problem given here? H of n is equal to a power of n into u of n, where a varies from 0 to 1. Okay. Here, see the difference. It is n. It is not t. Okay. So first we will write the formula. S of n is equal to summation k varies from minus infinity to k is equal to n h of n. What is your h of n? We have to write the mathematical expression, right? I forgot it. H of n is equal to a power of n for n greater than or equal to 0. Okay. Now let us substitute this one. Summation k varies from minus infinity to n. What is your h of n? It is nothing but a power n. But here it is h of k. Sorry, this formula is h of k. So this will become a power k. So if you see the formula, you have 1 minus a power n plus 1 divided by 1 minus a. So this is from your mathematical class. So this expression, how can you solve? Summation infinity to n a power k. This is from your mathematical class, 1 minus a power n plus 1 divided by 1 minus a. So this is your summation formula. So please go back and do your homework. Okay. So I think these problems are enough for step response. So let me go back to that homework problem and let me solve that one also. So since there is time for us, okay, and then we will have a quick revision what we have done today. Okay. So yeah, let us take this problem here. So let me take this problem. Okay. Sorry. 1 minute. Add to new page. Okay. Okay. So this is your problem here, where H1 and H2 are in a parallel block and H3 is in series, H4 in parallel, and your value of H1 is del of n and H2 is del of n minus 2 and H3 is u of n plus 2 minus u of n, and your H4 is a power of n u of n. So let us solve this problem. Okay. So what I told you, first thing, we have to solve this block step by step. So let us solve this block. So H1 and H2 are in series, are in parallel. So what will become your H1 and H2? So your H1 will be added to H2. Okay. Now, what is this H3? It is in series. So let me write it as it is. Then your H4. So it is in parallel. So H4 is in parallel and this is connected to this as it is. So plus minus. Okay. Now this is your step 1. In step So this is your step 1. In step 2, this H1 plus H2 is in series with H3. Okay. So what we have to do? We have to do convolution. So H1 plus H2 you convolve with H3. Okay. So this you convolve and you keep it. Then H4 will be as it is. So your H4 is as it is. Then you are connecting this to block. Okay. Okay. Now this is your step 2. Now this H1 plus H2 convolved with H3 is in parallel with H4. So how can we simplify this one? H1 plus H2 convolve with H3 minus H4. Why minus? Here you see the sign minus H4. Okay. So minus H4. So this is your impulse response. But wait a minute. What they have given? They have given you H1 of n, H2 of n, H3 of n and H4 of n. So what we have to do? We have to simplify that by substituting in this H1 plus H2 convolved with H3 minus H4. So let us do that. Okay. So let me take a new page for that. Okay. So what we have to do? H1 plus H2 we have to convolve with H3 minus H4. So first what we have to do? Bracket of, then we have to, this one you have to do convolution, then you go for this, finally you have to go for subtraction because it's outside the bracket. Okay. So first we will do this H1 plus H2. So what we have got? H1 plus H2, H1 is del of n and H2 is del of n minus 2. So H1 plus H2 is del of n plus del of n minus 2. Then H1 plus H2 convolve with H3. So H1 plus H2 convolve with H3. So del of n plus del of n minus 2 you convolve with H3. So what is your H3? H3 is nothing but, in question they have given u of n plus 2 minus u of n. So let us do this convolution. Okay. So del of n convolve with u of n plus 2 is equal to u of n plus 2. Del of n convolve with minus u of n, which is equal to minus u of n. Then del of n minus 2 when convolved with u of n plus 2, you will get plus u of n because plus 2 and minus 2 cancels. Then del of n minus 2 convolved with this u of n, you will get as minus u of n minus 2. Then plus and this minus cancels. So you will get u of n plus 2 minus u of n minus 2. Then what you have to do finally? Minus H4. So H1 plus H2 convolve with H3 minus H4. So u of n plus 2 minus u of n minus 2. So this you have to subtract with H4. Your H4 they have given directly as a power of n u of n. So this is how you solve it. Okay. So let me do another homework problem for you so that there is no homework at all for you. Okay. So let me take this sum, sixth problem. So let me add it to next page so that I can solve it. Okay. 1 minute. Yeah. Okay. Okay. Yeah. So they have given the same block diagram. Okay. So what is H1 they have given? H1 they have given as, 1 minute, I'll write here, U of t, and H2 also they have given as U of t. Okay. H3 they have given as del of t minus 2, and H4 they have given as a power t minus 2 into U of t minus 2. Okay. So sorry, so you have to solve this. So this block diagram is same as before, so I will not solve it again. So what we have got before is that it is H1 plus H2 convolution H3 minus H4. Okay, so this is what you have got, because it's the same block diagram. So if I solve again, there is like no meaning in it. So let us take this H1 plus H2. So what is this H1 plus H2? U of t plus U of t. So this is equal to 2 U of t. Now H1 plus H2 convolve with H3. So H1 plus H2 we have to convolve with H3. So we have got this H1 plus H2 as 2 UT. You convolve with H3, which is del of t minus 2. So what do you get? 2 U of t minus 2. Okay. Now what we have to do? Finally, whatever you get minus H4. So H1 plus H2 convolve with H3 minus H4. So whatever you get here, minus of H4 we have to do. So 2 U of t minus 2 minus your H4, which is a power t minus 2 into U of t minus 2. Okay. So what we can do here? U of t minus 2 is common. So you can write directly as 2 minus a power t minus 2 into U of t minus 2. So I hope you have understood this section properly. So what have we done today? So the first thing we have discussed about this system viewed as an interconnection. Okay. Then we saw when they are connected in parallel, we can add them up. When they are in series, we can take the convolution. Okay. Then what did we see? So we saw some problems. Okay. First, we saw without giving the values for H1, H2, and H3. So then we solved some problems with respect to that. Then what we did, we gave some values to that, like H1, H2, H3, and H4. Then what is the main motive behind solving this problem? You have to simplify the block diagram and then substitute the values. Okay. So then we solved some problems with respect to that. Then what we have seen, we saw the impulse response. Where is it? Okay. So we saw this, we saw the step response of the LTI system. So what is the formula? Summation k varies from minus infinity to n h of k. So this is for discrete time system. For continuous time system, it is minus infinity to t h of tau d tau. So using that, we have solved some problems. So first we saw some problems with respect to continuous time, and last I solved some problems with respect to discrete time. So what you have to do is solve more and more problems with respect to this. So yeah, so we are in end of this module 2, and this self-learning and some of the difficult problems in convolution, I will post it in your Moodle. Please check that. And yeah, we are end of this module 2. We'll begin with a fresh module in our next class. Okay. Thank you. Bye.